Along the upper Duckabush River, pillow-shaped volcanic rock records a lava eruption that happened underwater, even though the rock now sits on land. Pillow lava is made of separate, rounded masses, commonly up to about 1 meter across. These shapes are typical of lava formed beneath water, including at mid-ocean ridges and volcanic hotspots. Water rapidly chills a lava tongues outside into a solid skin. Hotter magma keeps pushing inside, inflating the lobe until pressure ruptures it. The new opening lets another lobe grow. Each rupture opens a new lobe, building a chain of interconnecting pillows. Repeated eruptions can produce thick sequences of these discontinuous masses. Oceanic rock can later be thrust over continental crust. Uplift can expose it above sea level. The Duckabush outcrop is not evidence that lava erupted on the riverbank. Its rounded forms preserve a former underwater environment now visible beside the river. That is why geologists use pillow lava as evidence for underwater volcanism. In 2020, one lightning flash stretched 829 kilometers across Mississippi, Louisiana, and Texas, 515 miles across 3 states. It was far beyond the scale of a nearby visible bolt. This was a megaflash, a lightning flash with a horizontal path of roughly 100 kilometers or more. Megaflashes are also commonly reported lasting over 5 seconds. The label groups unusually long reach or duration. Megaflashes form in mesoscale convective systems, large organized thunderstorm structures rather than isolated small storms. The records identify that storm setting but not the flash's exact internal channel path. The distance is measured while the complete electrical map remains unknown. Distance is only one extreme. In 2020, a separate flash over Uruguay and northern Argentina lasted more than 17 seconds. That duration record shows a flash can remain measurable over time, while the Texas region record measures horizontal distance. Better lightning sensors are revealing flashes that older instruments could miss. Records of extreme lightning are still an emerging measurement field. Because megaflash records depend on detection, future observations may extend either record. The same hypot function calculates a point's distance and combines independent measurement noise. It also expresses a moving particle's relativistic energy relation across geometry, experiments, and physics. It follows Pythagorean addition, take the square root of 2 squared values added together. In a 3-4-5 right triangle, the operation gives 5 from 3 and 4. Given Cartesian coordinates, these differences form the legs of a right triangle. For 2 points, subtract their x-coordinates and y-coordinates. Hypot combines those perpendicular differences into Euclidean distance. The aton2 function supplies the direction needed for polar coordinates. Independent noise sources do not usually add like ordinary amounts. Their standard deviations combine in quadrature, meaning the square root of squares rule when the sources are uncorrelated. If sources correlate, this rule does not apply. This produces a combined uncertainty value for an experiment. Relativity uses the same structure. Total energy is the Pythagorean sum of rest energy and momentum terms. Rest energy is the energy associated with mass, momentum describes motion. One operation therefore links a coordinate difference, a measured uncertainty, and a moving particle's energy. One small malonyl group can flip a protein's lysine site from positive to negative. That molecular charge reversal is now being studied alongside obesity and type 2 diabetes. Malonylation is a reversible post-translational modification, a chemical tag added after a protein is made. It occurs in both eukaryotic and prokaryotic cells. The tag attaches to lysine's amino end. Under normal cellular conditions, lysine carries about +1 charge, malonylation replaces it with roughly -1. That reversal can disrupt or reshape ionic interactions inside proteins and with other molecules. The donor is malonyl-CoA, a molecule that cannot cross membranes, so each cellular compartment must make its supply locally. In mouse liver, about 60% of malonylated proteins are mitochondrial, linking the modification to glucose and fatty acid pathways. So a tiny chemical change can redirect protein interactions across metabolism within living cells. But links to obesity and type 2 diabetes in human disease remain an active research question, while malonylation's treatment potential remains unexplored so far. At the Byzantine church of Khirbet et Tyre, a destruction layer was probably caused not by abandonment, but by the 749 Galilee earthquake. A destruction layer is an archaeological stratum containing signs such as widespread burning or structural collapse. It records an event but does not explain its cause. Archaeologists therefore treat it as evidence of widespread disruption rather than a complete explanation. Researchers compare the church's collapsed material with occupational phases before and after the layer. That sequence helps test whether an earthquake fits the site's history. The surrounding sequence matters because a catastrophe separates one occupation phase from another. Once dated, the layer can anchor the site's chronology, linking what came before and after to a historical sequence. Comparable layers at other sites may indicate a regional crisis, but each cause requires separate evaluation. This comparison turns broken masonry into a datable point within cultural change. That is why the earthquake link remains probable, not certain. Ruins can preserve a catastrophe's timing, while fire, warfare, or other causes must still be distinguished from seismic damage. In 1983, Anne Bayley's Zambian clinic found aggressive Kaposi's sarcoma in patients outside the prevailing HIV transmission picture. At the time, many believed HIV spread through sex between men or blood transfusions. Yet 13 aggressive cases included 3 women at Bayley's clinic. Kaposi's sarcoma is a cancer-like disease that had mainly affected older men in the clinic. In 1983, new cases doubled and 13 patients showed a more aggressive form. Its sudden increase gave Bayley a measurable pattern to compare with the patient's immune findings. Blood tests found the aggressive cases had the same immunodeficiency seen in American AIDS patients. An antibody test looks for immune proteins produced after infection. When an HIV antibody test became available in 1984, nearly all of those patients tested HIV positive. This connected the unusual tumor pattern to HIV infection, not just to the tumor itself. A later 1985 study in Uganda evaluated 109 patients for signs linked to HIV infection. 29 were estimated to have HIV, and all 29 later tested positive. That result strengthened the pattern beyond one Zambian clinic. Together, these clinical reports helped prompt wider recognition that heterosexual transmission occurred in Zambia and across Africa. They also sharpened the need for prevention guidance reaching couples, not only the groups first associated with AIDS. In 2001, FIDE began drug testing chess players, years before controlled evidence showed that substances could improve chess performance. The reason was institutional, not a proven chess advantage. FIDE was aligning its competitions with International Olympic Committee and World Anti-Doping Agency rules. This alignment supported chess's effort to meet Olympic sport standards, even with a low-risk classification. WADA classified chess as low risk. One proposed route involved beta blockers, medicines that reduce heart rate and anxiety by blocking adrenaline. Under pressure, that could alter the body's response while a player calculates. A 2017 study examined more than 3,000 games from 40 players. Compared with a placebo, an inactive comparison modafinil raised performance about 15%, methylphenidate 13%, and caffeine 9%. Players also played more slowly. So cognitive performance can shift with physiology, but the result is not simply stronger. The measured gains came with slower play, and the study does not establish identical effects for every player or tournament. It measured games under controlled conditions, not a universal rule for every player. Brazil's Navy began a nuclear project in secret, yet the program became public before its Aramaur facilities opened to broader scrutiny. It started in 1979 as the Chalana program, inside the military dictatorship's parallel nuclear effort. The Navy's goal was to master the fuel cycle for a nuclear-powered submarine. The effort used secret accounts and operated outside the safeguards covering the official nuclear program. The technical breakthrough arrived in 1982. Ultracentrifuges produced Brazil's first milligrams of enriched uranium after engineers chose a method that could be developed domestically. An ultracentrifuge separates uranium isotopes by spinning material at high speed. Democracy changed the program's visibility. After Brazil returned to civilian rule, the project became public and Aramer was inaugurated in 1988. The complex included a completed research reactor. Local construction drew questions, while officials offered limited explanations about nuclear propulsion. Its survival then depended partly on dual-use technology, serving civilian power as well as naval research. Brazilian ultracentrifuges were later supplied to the Resende nuclear fuel factory. Secret machinery had become a public technology program with a civilian outlet.